In this video, we continue on with our introduction to relational databases. In particular, we're going to think about some of the ways to categorize databases and also look at COD's rules, where COD is one of the main sort of developers of the idea of a relational database. Okay, so some ways to sort of categorize databases. One is sort of how many people are using it at a time. So if you have a database and sort of only one person uses, then you might call that a single user database. If you can have more than one, you would call it multiple user. And then there's sort of how many. So if it's sort of shared by sort of just a department at a larger corporation or something, then it might be like a work group database. But if it's spread across, many departments in the entire company, then it might be an enterprise database. SQLite is often a database used in development, and depends, like it might be a single user database depending on what you mean by a single user database. There are sort of actions you can have on a database where like insert and update and delete that change the data, that we would say write, and then there are select, which just read data. And so in terms of reading, SQLite is multiple. Any sort of number of users can read at a given time, but sort of writing is sort of like one at a time. So that is like at least quasi single user database. Okay, another way to categorize them, a database, is sort of like how many computers is it sort of physically on. So in some sense it won't affect the way like people use the database, but it will affect the way that it is implemented. So it might be a centralized database. It may be mainly on one computer, and maybe there's a copy of it somewhere. Maybe it's but it's sort of placed. All the data can be found in one place. That would be a centralized database, or it might be distributed. That it could be spread out over multiple computers. And we're talking mainly here about relational databases or SQL databases, but NoSQL databases, or not only SQL databases, one of their advantages is that they are sort of easier to distribute. All right. So then sort of what data is being stored and how is it being used is another possible categorization of databases. So you might have a transaction database or a production database, and that is one where you might be storing data of what's sort of going on sort of right now. So you have, let's say at a university, you might have the students who are taking courses sort of right now, or sort of in the some past, some like what they've taken in the last few years, but or for if you're selling something, the current orders and things like that, or you might have a larger amount and more historical data, and maybe even store it with some different rules, and then you might have a warehouse. Okay. One thing that's important in data and in a database, and making a decision to, if you didn't have a database, to have a database, is that you're sort of bringing your data together. And sort of, you might think a con, in pros and cons, a con might be that you're making it more complicated for a naive user, or you might be giving, your sophisticated user, sort of, you're bringing all this information together, you might be giving them more access to things that they ought not have, salary information, social security numbers, what have you. And this is where the concept of views come in. So you can have tables, bring together all these tables with all this information, and then limit access. So for that naive user, you may be just making it simpler so that they don't have too much to think about. And for the sophisticated user, it could be a security device that you are uh, limiting the access to things that they sort of ought not be able to see. Okay, and that brings us to database design. And again, we're still sort of introducing this concept of relational databases. So there were like file-based approaches where sort of separate information was put in different files, and then somehow those files were um, linked and sort of information drawn from different files and then related. Um, but then the relational database idea was developed, and for that, then and relational database is a database based on this idea of tables. And so we organize our data in tables, and then those information in different tables can be related using, say, foreign keys and primary keys. Um, and so then we have this concept of the relational model, and we have the sort of identification. When we are modeling, we need to identify uh, what data belongs in the different tables. And then we often end up, so we are usually modeling some other situation, something in the real world, a store, a university, what have you. And for the relational database to work well, we need a good model. So design is sort of crucial. That's another thing that sort of comes up in some of these NoSQL databases, is that uh, they're not as heavily design dependent, that you can sort of, add things on the fly. But one of the rules that we're going to see, one of the things we talk about in relational databases, is the ad hoc query, the way that we can sort of ask questions that weren't in the design. So that's something that you, to a certain extent, give up a bit in a NoSQL database. So you've made it more easily distributed and scalable, but on the other hand, maybe you can't ask it all the questions that you can a relational database. So they both have their roles, depending. If you just need something that's gargantuan and you're only going to interact with it in a certain way, you can go NoSQL. If it's a smaller thing and you want to be able to ask any question that sort of comes to mind later on, then maybe you want still the relational database. Okay, so there were sort of different databases designed sort of historically, hierarchical and network, and then in some sense the data was organized. There's a certain particular kind of relationship in those, and then COD came along and developed the idea of relational database and brought in this idea of the table. So there are the data is arranged in these tables. So you have that idea of a table, that sort of rows and columns. So you have the information, similar information, an entity sort of stored in a table, which has sort of set columns, and then you put instances of that data in the rows, and each row should be unique and identifiable. So it should have some kind of primary key. And um, and then you can have relationship between different tables by playing around with this So the primary key should be a unique identifier of a row in a table, but a connection from one table to another table can be achieved by a foreign key, which is often the presence of a primary key from some other table in the table we're talking about. Okay, so here's some picture of Cod, and he developed relational databases and the theory behind them and sort of established the rules that we're going to sort of talk about here. Okay, so we want structural independence. We want to be able to change something, like add a field, either change the length of the field or add a new field, and not have that sort of break everything. We want it to be, there's a lot to design. You got to get it right, but it should also be uh, simple. Like once you understand database modeling, ER modeling, then it shouldn't be too bad. And it should be easier than sort of, at least historically, what came before relational databases, which were the sort of hierarchical and network databases. So the database should provide for you, make it easy to use, make it easy to implement, make it easy to management. Of course, you got to have the good design. And then again, we're saying here what I said before, we want this ad hoc query capability. We want to be able to ask a question that just sort of came up that we didn't think of originally. So we have, as we've discussed at other times, the concept of entity and relationship. And this is sort of related to somewhat to the idea of table. So we are taking some real world thing, a person, place, or thing, and or a noun, if you will, and we are going to figure out like what the entities we want in our model, and this will inform us to at least some extent what the tables will be. If we are making an entity relationship diagram, an ER diagram, to sort of convey to others how we think the database should be designed, we typically represent the entities by a rectangle. There are different versions after that. That's sort of common to most ER diagrams. And then I usually work with the ER diagrams where like the top line of the rectangle will be the name of the entity, and then underneath it will be a bunch of properties, attributes, columns, and fields, all these different names for the things. So if an entity was person, then you might have a primary key for the person, person ID, and then you might have first name and last name and birth date and social security number and what have you, things that are related, pieces of data that are connected somehow to that person, that entity. Then you have a relationship. So you've identified these different nouns, these person, places, or things that you have collected data on, and then, but they have something to do with each other. So the person works in a department, the student takes a class, the customer has ordered a product. And then, so those things are the relationships between the entities. Okay, so Cod and his rules. So the data, all the data should be in these tables. So you have the rows and the columns and the primary keys, and that all is in a table. And we should be able to get at any little piece of the data, sort of the first name of a person. So we should be able to, by saying the table, it's the person table, the primary key. Oh, here's the student ID of the person. And then what column name do I want? I want their first name. I should be able then to sort of track down between the table, the primary key in the table, and the column name. I should be able to isolate sort of each little individual, sometimes people use the word atomic piece of data. Okay. We have to be able to deal with nulls, and we have to be able to say um, when there can be and can't be nulls. So it's possible, we should have a way to handle a null, that if a piece of information is just not there. And this is different from, like, if variables have a type. And so if your type is an integer, a number, um, this null is different than zero. If your text, if your field has a type of string or text, the null is different than quote quote. Let's say you're collecting middle initials. It is uh, different to say, I don't know this person's middle initial, so null, versus this person doesn't have a middle initial, quote, quote. I mean, so there is and should be some distinction between, say, an empty string and the null. Okay, so we should have um, an organization, like, here are the tables and their relationships and so on, and that should be like accessible. So I should be able to not just query the data, but I should be able to query the schema, the structure, the metadata. I should be able to ask, how is this database organized? Now we had that concept of view. We might um, hide that data from certain people. Maybe we don't. Maybe them knowing the structure would give them like, too much information. But in general, the information should be available at least to the right people. There should be a language to handle all of the aspects of databases, and this, for the most part, is SQL, structured query language. Um, and then we break the language into different pieces. There is data definition, sort of. So part of SQL is establishing what the tables and the properties and the relationships are. There's data manipulation, putting data in, insert, changing data, update, getting rid of data, delete. These are all, and select, seeing what the data is. These are data manipulation. Um, there can be also part of sort of data definition and data manipulation, sort of like a combo, is data integrity, sort of to make sure, so you have some rules in your definition, and then you are inserting data in your manipulation, and then the integrity is sort of like, does the manipulation of the data continue to satisfy the rule set up in the definition? And then there is sort of like data control, like security, those sort of things. What user can see what data? How are they authenticated? What do they have the authorization to do, and such? We have this concept of a view. So the user can be limited and maybe not be able to see all tables or even everything in a given table, or maybe some limited combination of two tables, and these are known as views. So you organize your data in tables, but that may not be what you show your users. You may be showing them a view, and then they should be able to work with the view as if it were a table. So they should have all the abilities, that somebody higher up can do to a table. The person who's working with the view ought to be able to do that to the view. Certainly, that is straightforward for anything that is reading. Um, that might be a little bit more difficult for any kind of like writing, sort of updating or deleting and so on. Okay. So we should be able to, we have our uh, data manipulation in addition to select, which is sort of more of a read, a look at things. We have insert, update, and delete. And we shouldn't be sort of limited to, like the most minuscule of like insert, updates, and deletes. We ought to be able to sort of do sort of larger scale inserts, sort of multiple rows, updates, deletes, and so on. We should not, the database management system should be set up that when we are working at sort of, if we are not the implementers of the database, if we're just using it at the logical level, then physical changes should not matter to us. If they sort of move the system, if they update their hardware and move the database to a new system, so long as like when that process is complete, then I, as some user of the database, should not sort of be affected by that. We should have uh, a some logical independence as well. That uh, if I can see a certain table or have a certain view, and if nothing in my view is explicitly changed, but other logical changes are occurring, it should not affect me. I should be able to sort of, if the things that I'm working with don't explicitly change, then I should be able to just carry on without seeing any difference. So it should be independent of those changes. Um, we want we always want integrity. We want our data to be sensible and to make sense, and so we put constraints on the data and when we make our design and so forth, and those should be supported by SQL. And um, we want those to uh, be kept. Now, there are um, certain data integrity things that are harder to implement, but at least most SQL implementations do are pretty insistent on at least the basics that if you have a primary key, it cannot be null. So we said we can have a null, but not in a primary key. If we say we're establishing a relationship through a foreign key, then it must match a primary key. So even if you say uh, I have this foreign key and I'm connecting to another table, to a field in another table, and insisting that it match something in another table, but if that something is not a primary key, then that could be a problem. So because the primary key is where you're insisting that they're unique. So when the foreign key to establish a relationship ought to be unique, connecting you to something else. So they usually insist it be the primary key. Um, some of the data we said, like in categorization of databases, we said some of them are distributed, and that should not have an effect, that it should be the user of the database shouldn't care whether it's distributed or not. And then we have this way through the structured query language, through SQL, to define the database and set up the control and sort of do all those things to to modify the schema, and those things should all happen through SQL and no other way. So it's sort of this sort of self-contained thing that there's not another way to deal with the database other than the SQL. So you're protecting like how the database is defined, is modified, and everything else. So then if you're controlling the SQL, you are controlling the database, because that's the only way to work with the database is through the SQL. That's it for this one. These are just some of my references. Thanks for your attention.